Good morning, everybody. So I've only got 5 minutes. I'll be as quick as I can and give you as much information as I can. So the study is on sensitivity of various apple rootstocks to water stress. This was a study conducted by a PhD student, Lindsay Mochena, who graduated in March this year. And I'd like to just acknowledge my collaborators as well, Seb Sikiti and Elmi Lotz. So the background is very similar to the previous study. Water resources are becoming constrained. There's increasing demand and competition. So we need technologies that allow growers to use or do more with less water in the first place, but also to make sure that when there is not enough water, like we had in the drought years, we remain resilient, we remain in good production and good fruit quality. One of the aspects of choices that growers make when they establish orchards is which rootstocks to use. And this is something that hasn't been explored to a large extent in terms of what water savings and drought resilience could be conferred by wise rootstock choices. So the aim of this study was to quantify whole tree water use, leaf gas exchange, and growth of mature bearing and non-bearing rosy glow apple trees on a range of rootstocks, and they varied from semi-vigorous to dwarfing under well-watered regimes as well as under water deficit. And then we also looked at the fruit quality and internal defects after storage. This is done in 2 seasons for each of those. The methods, I'm only going to talk about the field site. This was at Paardekloof, the rootstock evaluation site on Rosy Glow. And you can see there the characteristics of the orchard. It's a deep sandy soil. The treatments that were done, 5 rootstocks were chosen, ranging from M793 as the largest, or most vigorous one, and to the dwarfing ones, which you can see on this one, which is the M9 RN29, also MM109 on an M9 or interstem, and G222. And then we also looked at M7 for some of the measurements. So we imposed the treatments in 2 cycles in January to March of 2 years by just cutting off the irrigation to the deficit treatment. We measured transpiration using sap flow measurements. We calculated crop coefficient. Then in the soil, volumetric soil water content and water potential and the rooting profile, leaf gas exchange and water potential, and then also the climatic measurements for calculation of reference evapotranspiration, and then the harvest quality, water productivity, and shelf life. So just a very, very key results coming out of the study is that, first of all, in terms of absolute water use, the most dwarfing rootstocks use the least water over the season. This was very clear. The yellow one there on the bottom is the M9 RN29, the most dwarfing one. Water use over the season in cubic meters per hectare was 4690. And if we compare that to MM109 with an M9 interstem, that was 8950. And the other 2 were in between. These were calculated based on the industry spacings, not the left-hand column shows the trial site spacings, and the right-hand side shows the industry spacings, which does make a difference. In terms of water productivity, we found that the highest water productivity was also the most dwarfing rootstocks, so M9 RN29 and 109 M9, around about 15 kilograms per cubic meter, and then the lowest one was M793. Then when we imposed the drought, we found that transpiration of field-grown trees was not reduced by water deficit. And then during recovery, M793 and M9 RN29 showed some interesting responses where they showed increasing water use during the recovery phase. So something must have happened in terms of root development or maybe shoot growth to give that higher use. And then just very briefly in the storage trials, 2018 and 2020, the results weren't clear-cut statistically, but there were some indications that fruit from trees on MM109 M9 and M793 were less susceptible to internal browning following the summer water deficit. And yes, we looked at different types of internal browning. This is the one that came out with the statistical results. So in conclusion, we see that more dwarfing rootstocks confer production and water use benefits without increasing risks to water deficits. The use of M9 RN29 in high-density plantings could result in a significant saving in irrigation water and a high water productivity. But one does need to be careful in terms of the post-harvest risks that recommendations are followed for optimum maturity at harvest. And we need further studies on what happened on MM109, M9. There were some really interesting results physiologically in what happened on that particular rootstock. Thank you very much.